as Monty Python would have said. And now for something completely different. Today we're going to look at a Pride controller for a Pride lift chair. This is the type of chair that a senior or someone with mobility issues would use to help them get to a standing position and recline. And I've got a controller that's not functioning. So we're going to take this one apart, see what's wrong with it, and get this one going, because these things are really expensive to replace. This is a control for a Pride lift chair. This is the type of chair that someone with mobility issues would use. It's a reclining chair and it will lift them up to a standing position. It was my father's when he was alive. He had it for a number of years. When he passed away, my mother used it for her remaining years. And then when she passed away, it's now with my mother-in-law. But it's broken. It won't lift up anymore. And I have a feeling it's probably because the cable is broken here. So we're going to pull this one apart and see if I can get this one going again. She has a spare, but the spare is also broken. So this is the original one that was on it. Something like this should be pretty simple inside. I'm thinking maybe 3 wires is all it's got. I mean, really, that's all it needs. Maybe 4 wires. Really, it only needs 3, right? Ground and up and down, or power and up and down, but it might have 4. So let's see what's in here. It's got 5 wires. Why does it have 5? That's kind of unusual. What would this need 5 wires for? I mean, really, all it is just 2 switches, right? That's all that's in this thing, is 2 switches. 1 switch for down, 1 switch for up, but yet they're using 5 wires. Maybe they're not using all of them. It's just a 5-wire cord, more than likely. But let's check it out and see how it's connected. What I see on this is that the blue and the green wires are not going to anything. If we follow the traces here, one wire, the blue wire comes right over here and goes to this pad, and the green wire goes all the way around and comes up to this pad. And it's not connected to anything. So there's actually only 3 wires that are connected. And I don't know whether the other one, I seem to think that the handle had like a mini plug with a little key that plugged in there so that it could be disabled by removing this little shorting plug, so that kids couldn't play with it. And maybe this was the secondary handle that was purchased that doesn't have that key. Well, let's just check and see if we've got continuity on all 5 of these pins. So that one works there, and the next one over is probably this one. The next one over is probably this one. This is where one of those third hands would come in handy to hold it. Third one over is this one here. Is it that one? Oh, that one's open. What's that one? Okay, what's this one? That's that one. And that's this one here. So then these 2 must be that one and that one. So this cable doesn't appear to be broken. These things are generally pretty straightforward. It's just a down and up, just 2 switches. So if I check the switches out, the switches themselves, when I press the 2 switches, this is the down switch over here. So when I measure these 2, if I push the switch to down, it should beep, unless the switch itself is broken. Oh, why isn't it beeping? Or is it the other way? Maybe the switches are broken. Okay, I'll clip on to the common. So here's the common rail. Goes to that switch, goes to this switch here. When I close the switch, I would expect to see continuity, and I see nothing. Same with the other switch. It's like both of these switches are bad. That's interesting that the actual switch itself would fail. You normally wouldn't see a mechanical switch fail, never mind two of them, unless there's such excessive current flowing through this thing to operate the motor that when the motor stops, it creates enough of a kickback that it causes the contacts to arc and pit, which is possible. Let's take a look at the switches themselves. I may have to make a run down to the electronics shop and see whether I can get some switches if they've got anything like this. They're pretty standard switches. I mean, there's nothing real special about them. They're just normal, like Omron lever switches, similar to what you'd see in a microwave oven, but with just the levers on them. What should be noted is it's just the normally closed or the normally open contact. The normally closed contact is working. If I check it normally closed, press the switch. Same with this one. Right, but when I go to the normally open contact, nothing. So it's definitely something with the switch. I'm starting to think that probably these two are not used at all. This looks like there was another type of jack that went over here, like another connector, like one over here as well. It may have been used for this one here. I think probably was the one used for the lockout, because if you look at it, it's bridged already, and it's going from the common, right? This one here, this is the common that goes to both switches, right? This is the one that has the lockout on it, and it's bridged. I think these ones were probably for a different style cord. This looks like a 6-pin plug. It may have been for units that had lights when you press the button, or a different controller that operated differently. So I think all we have to deal with on this is to get some switches. These switches don't come apart, unfortunately. Unlike microwave switches, which you can typically pull them apart, these ones here appear to be fused. So I'm going to have to make a drive into the big city, I guess, and see if I can find some, which will give me something to do. But we'll return once I get some switches, and we'll get this thing fixed. That, by the way, is a $5 Canadian stamp. I had somebody send me something in the mail, and they put stamps on it, and that was one. And that's actually a fabric stamp. It's not paper. And for some reason, it didn't get canceled. So I've stuck it up on my door. Back from Lee's Electronics, a couple new switches. They didn't have the exact switch that was shown on the website. They had these other ones, which are essentially the same switch, but it has a little extra hook, which I'll have to nip off with my snips. So if I do this, I've now converted the switch to that same length, right? So we'll just clip this other one as well. What did I wreck my snips doing that first one? There we go. Okay. Don't want to wreck my Klein snips. These are expensive. These are like, I think, about $40 a pair. All right, let me just get that other switch out, and we'll mount these ones. I'll have to modify the base as well, because you see the tabs are different. This one here's got eyelets for soldering, and this other one had just holes or pins to go through the holes, so I'll have to cut those down as well, but that should work. We'll use some solder wick to remove the excess solder. In case you guys are wondering, I will take the old switches apart, see how bad the contacts are burned up. And I'm assuming that's what happened. Was there's probably no capacitor on the inside. When you release the switch, well, there, the switch just came apart. If I clip off part of the tab, there should be enough. Should be narrow enough to fit through the hole. Do wear safety glasses when you're doing this type of stuff. I got my reading glasses on here, but still, you really should be wearing safety glasses when you're cutting metal, because the little pieces end up going anywhere. Okay, so there's one switch. See if I can get this to mount into the board here. I may have to work on these a little more, to nip them down just a little bit more. I don't need the normally closed contact, so let's just clip that one off. Then I can get the other two to go through here. Where are we here? There, those two should fit, because I only need the two contacts to fit. Of course, it's the normally open and the contact and the common that are, the other two were the ones lining up. It's the common that's a little bit off on this one. It's a little bit further out. Wonderful. You see that? It's just not quite making it through. Bend it over just a bit. Okay, that should work. Okay, I had to trim the contact a little more, but I think that'll do it. I've got enough protruding through the board that I can solder it on. And we'll do the same for the other switch. So we'll take the wherever I did with it. We'll take off the normally closed contact, because we don't need that one anyway, so we'll just cut that one right off. And then the other ones, we'll trim them down. And will this one fit? Should fit. Okay, they're protruding enough that I can solder them down. Now the big question is it going to work? When I put the switches back in, are they going to activate? I think so. Yeah, I think we're good. We'll just put the screws back in, and then I'll test this. I'll hook the meter up to it. And we'll test the switches and see that they work. But I think this will do the job. Heck of a lot cheaper than buying another one of these controllers, because anybody who's ever bought anything in the mobility, and I'm not talking like mobility as in cellular phones, I'm talking mobility as in for assistance for seniors. Anybody who's ever had to buy anything knows how ridiculously expensive everything is. Like a controller like this, I don't know what it is. I know that when my mother had the chair, they bought her a used one, and I think the used one they paid like $100 for it. It's just ridiculous what these companies charge people. Almost a crime. Okay, let's see whether this thing will work now. I'll clip my common on. This was the common here. The meter is in continuity mode. So let's see here. Common is this one. So this is one side here, which comes back and it goes to this pin. So that should be down. And this one should be up. Up and down. And if we go back to the end of the plug, one of these will be common. That's common there. And then these other two should be up and down respectively. Don't know which one's which, so down, and then this other one here should be up. Good. So I will say that the controller is now fixed. I can send this one back to my mother-in-law and I'll help her get up and get about as she's getting on in the years, and as everybody gets older they need a little more assistance. So to say, she's the third person that's had this chair. It was my dad's originally, and then my mother had it, and now my mother-in-law has it. But no, I won't be getting it next. Be a while before I need something like this. At least I hope. It'll be a while before I need something like this. So let's just tear down the old switches and see what failed on them. Since I've already got this switch apart, this one did come apart when I was removing it from the unit itself. So we'll just remove or bend the normally closed contact out of the way so we can take a look at the other oh, there, the switch is broken too. But here we can see that the switch contact here is burned. That's all that went wrong, is that the contact here got pitted and burned, and then the other contact on the actual switch itself here is probably also. You can see it there from, that would just be from arcing. Right, these operate on low voltage, but yeah, it just went bad from just years of use. Just all the little sparks that occur every time the switch is opened and closed. Right, there's going to be a bit of a kickback from an electric motor, just like a transformer when you shut it off, and it just pitted the contacts. See, the replacement controller she's got now, it'll go, I think it goes up, but it won't go down. So one of the two switches on it. That's why I had to fix this one, because the chair is kind of useless without this controller. So that's about it. Let's see if we can open this thing up. Yeah, and this one here is the same. You see? Contacts are all pitted. Anyway, that's it. Thanks for watching. We'll catch you in the next one real soon. Bye for now.